All right, let's look at lesson 13.7, modeling randomness. So what we're going to look at this is expected value. In this lesson, expected value is the sum of each outcome's value multiplied by its probability. So if you're playing a dart game and each area of the dartboard has certain points. So basically, if you play the game, what is the value of your points that you're going to play? So how much can you expect to win? So the key concept here is if A is an action that includes outcomes A1, A2, A3, and so forth and so forth, the value of A is going to be the probability times area 1 of area 1 times the value of it, which means if it's 5 points, probability of that times 5 points, plus the probability of area 2 times its value, maybe 3 points. And then as you get further and further outside, the point value gets smaller. So let's take a look here at an example of how we calculate this. Suppose you're at a carnival and you're throwing darts at a board like the one here at the right. You receive 20 points for the areas that land in the white. Okay, and it's going to be smaller as you go out. You're going to get 10 points for anything in the red, and then you're going to lose points for anything in the blue. Okay, so how many points can you expect to be given if the areas are the following: 36 inches squared for the white. There are 108 square inches for the red, and the blue area is 432 square inches. So they've already calculated all our areas, so we just have to find the value. The total area of our target is 576 square inches. Okay, that's this area of this hole. So we've given all the information here. All we have to do is figure up our values. So let's take a look here at the first part. Okay, so the value is throwing a dart. Okay. Now, so as we look at this, we're going to look at the probability of the area of white, okay, times the value here, which means it's going to be 20 points. Then we're going to add the probability of the red, and we're going to multiply that by its point value, which is going to be 10, plus the probability of the blue times its point value of -5. So all of these areas here will get us our total expected value here. So let's take a look at this. So we'll start with the probability. Probability means it's the percentage of the part over the whole. So we're going to do, for the first part, we're going to put 36 square inches over the entire target, which is 576. We're going to get this value and we're going to multiply it by 20. Then we're going to take the probability of red. Well, the red has an area of 108, and we're going to divide it by the 576, and then we're going to multiply that by 10. And then we're going to do the last one here, which is going to be the probability of the largest area, which is going to be 432, and we're going to divide it by 576, and we're going to multiply this by a -5. So in each one, we're going to go ahead and calculate this value. So 36 divided by 576 times 20. So we get our calculator. Maybe. There it is. All right, we got 2 of them. Now we got 3. And we'll just take 1. All right, so let's take a look here. We'll move it over here so we can write these values down. So we're going to take our first one, 36, divided by 576. Now go ahead and hit enter. That gives us 0.60625. Now we're going to multiply that by 20. Okay, that gives us an expected value of 1.25. So we get 1.25. Let's go to the next one. So we're going to take 108 divided by 576. 0.1875. We're going to multiply that by 10 points. That gives us 1.875. And then the last one, we're going to get 432 divided by 576. 0.75, we're going to multiply that by a negative 5. That gets us a negative 3.75, so negative 3.75. So our expected value, if we add all these up, so we'll go back here and we'll take this value plus 1.875, okay, plus 1.25, gives us a negative 6.625, so negative 0.625. So our expected value is going to be negative a point value. So if basically if we play the game of darts, we're going to expect on average to lose 0.625 points. Or that's the points we would be awarded at the very end. So that means that because the way I have this set up, that means you're going to have a greater chance to lose than you are going to win, which is going to be true for most games that you play. The advantage is always in it's never with the person who's playing, it's always with the person or with the game itself. So let's take a look at our next one. So remember, take the probability times the point value for each one, add them up, and that gives us our expected value. So the next one here is, so how many points can you expect to get from the dartboard shown in example 1 if you receive these points? 30 points for white, 15 points for red, and negative 10 points for blue. So pause the video, work on this now, and come back and check your answer when you're done. All right, let's take a look here. So do you think the point value is going to go up because we have 30 more points? We added 10 more points for the white, 5 more points for red, and we've subtracted 10 more points. So let's look at the numbers we get. So probability of white, 36 over 576 times 30 is 1.875. Probability of red, which is 108 over 576 times 15, is 2.8125. So far these are much larger than what we had before. But when we do this over here, we increase this, and because this area is the largest, 432 over 576, it's going to give us a negative 7.5. So out of these up, we get a negative 2.8125 points. So even though these numbers went up and our area of winning is you get more points for, we increase the area of our blue region, which made us have a higher negative points value. So we should expect to get negative 2.8125 points. So now let's move on to our last one. So you saw as we made each number bigger, okay, what would be the number of points that could be set for the blue area that would result in an expected value of 0? Okay, so let's go back to this last one we used. Okay, so we had the expected value so far. So we're going to take our numbers of 1.875, these are the last numbers we used, plus 2.8125, and then we had let's see, 0.75 times x. Now, the 0.75, this comes from taking the 432 divided by 576, because we're trying to figure out what will we put in here. So we have to just come up with our probability times whatever x is going to be our expected value of how many points we'd need for the blue. And we want our answer to come out to be 0. So it becomes just that regular algebra problem. We add these together, and that's going to give us 4.6875. Remember, don't round off, just leave them as they are. 0.75x equals 0. So now we're going to subtract 4.6875 from both sides. So we get 0.75x equal to a negative 4.6875. Divide now by 0.75. And so x is going to be approximately, so as we divide this number here, put this over here, we get a negative 4.6875 .875 divided by 0.75. That's going to give us a negative 6.25. So negative 6.25 is what we should put in for our blue region in order for this expected value to come out 0. All right, let's go on to the next example. On the opening drive, a football coach must decide whether to kick a field goal or go for a touchdown. The probabilities for each choice based on his team's experience are shown from a page of his playbook at the right. Field goal will get his team 3 points. His team will get 7 points if the touchdown is successful. So that means assuming we're going to make the extra point as well. So which play should he choose? Well, let's look at the expected value, how many points you should get. And so a lot of teams, in a lot of games, they're always calculating stats. You hear them talking about stats. What is the percentage he's going to do this? So let's look at how they come up with some of these things. Field goal. So for the field goal, he has a 90% chance. So 90%. And we're going to multiply that by 3 points that he gets. So that is 0.90 times 3. Well, you multiply this, he's going to get approximately 2.7 points on average. Okay, because it's pretty good. It's not quite 3, but not 100%, but it's pretty close. So now let's look at the touchdown. Not quite good as average on these. So we're going to take the 35% times the 7 points he gets for each touchdown. So we're going to say this is 0.35 times 7. And that's going to get us 2.10. So we're going to get 2.1 points on average on this drive. So since 2.7 is much larger than 2.1, and this is going to be the field goal, then kicking the field goal is the best option. Okay, so that's just kind of common sense. You look at these two numbers, you got more points for this than this, so it's best to just take the points. And that's why most of the time it's important to get points on the board, so we just kick the field goal. Now, suppose the probability was changed from 80% for a field goal and touchdown was down to 30. Which play should the coach choose? So calculate this value now, come back and check your answer when you're done. All right, so once again, we take a look here. We got 0.8 times 3 is 2.4 for the field goal. The touchdown, we have 0.3 times 7 is 2.1. And again, kicking the field goal is the better choice because 2.4 is bigger than 2.1. So the last question here, are there situations where the coach should choose a play that doesn't have the greatest expected value? So what might that be? Well, let's say you're at the end of a game and you're down by more than 3 points. Even though the return on points is greater for the kicking the field goal, the TD is going to get you what's win the game. So you'd have to go for the touchdown. So, or maybe your field goal kicker just sprained his knee. That's going to affect your value, so you're going to go for the touchdown. So a lot of different ways could possibly be the answer for this. Okay, those were just a couple. And so this concludes our lesson on modeling randomness.